This video is to help you understand the basics of or the attributes of systems of linear equations. First, let's talk about what is the systems of a linear equation. A systems of linear equation is two or more equations comprised of two or more variables. In this lesson, we're only going to talk what we call a 2 by 2, which is two equations with two different variables. All right, so I'm going to give you some examples, and I'll do them in different colors so you can see them. All right, so here's an example. All right, so here's example 1. As you can see, we have two equations, and the two different variables are x and y. Both x represent the same thing in both equations, and the y's represent the same thing in both those equations. But the x and y do not represent the same thing. So x is of one type of variable, y is the other type of variable. So this is a systems of equation right here. All right, here's another systems. This is another one that a different way you could see it. 3x minus 4y equals 12. And this time I'm going to make it y equals 2x minus 4. Even though these are two different, ones in standard form and ones in slope-intercept form, if you look at them, let's look at the definition. Are there two more equations? Yes, there are. One's in standard form, one's in slope-intercept form. Are they comprised of two or more variables? Okay, so yes, there are two equations, and there's two variables. They both contain an x, and they both contain a y. And so when we're doing these, remember the x represents the same thing in both categories, and y represents the same thing in the other categories. So there we go. That is another way you could see, and these two are a systems of equations. All right, let's give you one more. Ooh, I'll pick this. This is good. All right, so this time I'm going to write 2 in y-intercept form. And I'm just going to put a fraction here just for the heck of it. So we have y equals a negative 3/2 x plus 2. And y equals 1/4 x minus 4. Again, let's ask ourselves the definition. The system of equation, is it two or more equations? Yes, there are two equations. They're both in slope-intercept form, but they're still both equations. Are they comprised of two or more variables? Yes, they both contain an x and they both contain a y. So yes, this is a systems of equations. So let me give you one and see if you can tell me if it's is or is not. And I'll do it in a different color. Alright, so I'm making one up. Is this a system of equations? Well, technically no, because one, they don't both contain x's. You could argue the point that one has 0x, and you could contain it that way. But in technically what we're saying is, do they both have a x or a y in each equation? And they don't. So this is not a systems of equation. There are three types of solutions. All right. Solutions means that they are and when we're talking about linear solutions, it's talking about how many times the lines touch. All right. In this case, we have two lines here. One's L1 and the other one's L2. I'll put them in different colors so you can see them. When the lines intersect, this is called a single point solution. They intersect right there, so that is a single point solution. All right, and they contain an x and y coordinates. That's where these two lines are both have in common. They intersect at that point, so they touch one time. All right, and to let you know that they're touching one time, there's other things. We also can say that these are consistent systems. And that they're independent. So the single point solution, the consistent system, and independent all mean that the two lines touch one time. And they only touch one time. Our next solution is what we call I'm going to try to draw it here for you. There's our line 1, and our line 2 is right on top of it. These two lines are touching it, and they go on forever. You got to kind of think of that. These two are touching an infinite number of times. So this is an infinite solution. We also sometimes consider this all real numbers. They touch on every number that can be for the x or y, depending on how they're drawn. And we use the double bar R symbol here for all real numbers. So we also say these are these are also what we know as coincidence. So C-O-I-C-I-D-E-N-T, which means they have the same slope and the same y-intercept. Right? Same slope and y-intercept. So coincidence is they have the same slope, same intercept, so they're the same line. They're also called a dependent system. So notice the difference between the two. The one on the top, it only touched one time, and we call it a single point because it touches one time. And it has an x and y coordinate. And it's also considered consistent system and independent. Where the other one, the lines are touching it, they're right on top of each other, they're touching an infinite number of times, so it's an infinite solution. So you could say it's all real numbers. You could also say it's the double bar R. And it coincides, which means it's a coincidence that it's the same slope, which means the same slope and same y-intercept. It also is a dependent system. All right, there's one more, and it's called, when we have two lines, here's my first one, and here's my second one. This one is a solution that we've seen so many times. This is no solution, because remember, the solution talks about how many times the lines touch, and these two lines never touch. So when parallel lines, you have systems with parallel lines, there's no solution. We call this, there's a couple things, we say it's inconsistent. So if it's inconsistent, that means it doesn't touch. And we also say this is an empty set. We use the symbol, like a zero with a line through it, as our empty set. This is our third solution. So there's three types of solutions when we have systems of equations. There's a single point, there's an infinite set where the two lines are on top of each other, and then there's the parallel lines. These are the only three types of answers we'll have when we do systems of equations. These are the three types of solutions or / answers that we could have.